guys, this is Mrs. Gassler, and in this video we're going to be talking about mirror ray diagrams. And so you should have this packet here. It's got 4 sheets in it: a concave mirror, a convex mirror, a bunch of concave mirrors, and then another worksheet with some more convex mirrors on it. We're going to do a couple just to talk about what is here and what we need to do and draw, and then we're going to do some examples together. Okay? So for starters, we're going to label all this stuff on this picture. This main line through the middle here is called the principal axis. And this little dot that is given, unless it's marked otherwise, but you can kind of see here, if this is like I drew, you know, with a compass. There's my circle. This is called the center of curvature. Center of curvature. It's like the focal point. The center of a circle. Okay, there is also a focal point, which happens to be half the distance between the center of curvature and the mirror, and this one looks like it's 7.123, so that would be 2.5, 3.5, so that's like here. At about 3.6 or 3.65-ish centimeters, that is the focal point. F for focal point. Focal point. Sometimes this is marked C and this one's marked F, and those are usually both on there, and sometimes only the focal point is on there, and sometimes only the center of curvature is on there. But the focal point, we'll make a note over here, focal point is at half of C. Okay, so if you only have one, you got to draw the other. Now, whenever we draw this, we need some sort of image, object to be reflecting. So I'm going to draw this as my object. It's an arrow. That's just kind of convenient, and that helps us think about things. If you want to draw the same arrow, mine is 1.8 centimeters tall. Okay, and it is 13.65 centimeters away. So my object distance is 13.65 centimeters, and my object height was, what did I say, 1.8 centimeters? Okay, so if you want to draw the same thing, you can. Now, when you're drawing a ray diagram, there's a set of lines that you need to draw. There's actually 3 lines that you can draw, but you only ever need to draw 2. And so we're gonna draw those. So the first line starts at the tip. It goes parallel to the principal axis. That's code for parallel, right? Okay. To the mirror. And then it is reflected, so it bounces back through the focal point. Okay, and what you have to do when you draw these is make sure that they go far enough that the next line will meet it. So I'm going to try and make this as parallel as I can. That looks pretty parallel to me, and I'm going to draw it all the way to the mirror, and then I'm going to stop. Sometimes I need it to go on the other side, so I just draw a dashed line there, just in case. Okay, and then wherever it meets the mirror, that's going to go to the focal point like this. Okay, and so I'm going to draw that off this way, and I'm going to dash it back here just in case. Okay, so there's my first line. That's line 1. The next line I'm going to draw is going to go, it's going to start at the tip. Whoops, I forgot the D. It's going to start at the tip, and it's going to go to the focal point. Actually, it's not going to go to the focal point. It's going to go through the focal point to the mirror. And then it's going to be reflected parallel to the principal axis. So it's kind of the opposite of this one that we just drew. Okay, so this time, oh gosh, do you see what I did? I drew it through the center of curvature. Let me fix that real fast. Okay, wrong line. Right line. It's got to go through the focal point. My bad. Okay, and that's wrong too. Good thing I used a pencil. You should use a pencil too. All right, so this next one is going to go through the focal point. There we go. That's right. And I'm going to dash it over here just in case. Okay. And then where it hits right here, it's going to go out parallel. As parallel as I can make it. Now, in a perfect world, I would be able to make it totally parallel, but sometimes it doesn't work out. All right, so there's my dashed line on the other side. Now, where those two meet after they hit the mirror, so this was before they hit the mirror, before they hit the mirror, after they hit the mirror, after they hit the mirror. If only I could do that in a, maybe I'll make it darker. This right here is where they meet. Okay, so I'm going to note that here. Where they meet is the new tip of my image. Okay, so I'm going to draw it. So this is what my object looked like. So I'm going to draw the same thing, just upside down. If it ended up being on top of the line, then I would draw it pointing up. But there's my image right there. So where those two lines meet, that is my image. Now I can tell some things about it. It's smaller, so it's reduced. It is upside down, so it's inverted. And I could put a piece of paper right there because this is a mirror, right? So it is a real image. Okay. So that is how you draw a concave on a concave mirror, those three lines right there. Okay. Now on the next page there's a convex mirror, and we're going to do kind of the same thing. It's got the same pieces here. The difference here is that the focal point is going to be on the other side. So let's measure. This is our C for center of curvature. It looks like it's at about 8.65, so that's 4.3-ish, so right about there. Okay, so there's my focal point. Okay. Now this one is going to be a little bit difficult. Remember, when our lines meet, that's where the image goes, but sometimes the lines don't meet on the right side of the mirror. So let's put an image down. We'll make things easier. We'll put it 10 centimeters away, and let's make it 2 centimeters tall. All right, there we go. So there's my image, or my object. Okay. It's 10 centimeters away. That's my object distance, and my image my object height. Can't write letters here today. My object height is 2 centimeters. Okay. Okay, so same lines. It's just going to be on the other side of the mirror. So I'm going to make that note. Same lines, but I'm going to have to extend to the other side of the mirror, and you'll see why here in a second. So my first line, remember, is parallel to the axis, and then it hits the mirror. Now this is where it's different. The focal point's over here, so the line would go like this. Okay. And there's my outgoing ray, but I'm going to extend this over here toward the focal point. And you'll see here in a minute. There it is. Okay. Now the next one goes to the focal point. Notice how it's going through the mirror. I got to stop at the mirror. So this time it's not going to hit the focal point because it's going to go through the mirror here. Or it's going to hit the mirror before it hits the focal point. So this is the spot where I'm going to go, and then it goes out parallel. But you can see that my two lines here, this one and this one, they're not going to meet anywhere over here. They're going away from each other. So I'm going to extend this one over here because they do meet right there. Okay, so this is where I draw my image. Okay, so I have to extend to the other side so they meet. That's what I had to do here. So this image is also smaller. It's reduced, but it is not inverted. It's upright, and it is a virtual image because, well, the light can't actually go there. This is a mirror. My eyes can perceive it, but it doesn't actually go there. So I drew the same set of lines. Same lines. I just had to change how I do that. The hardest part on here is knowing when to turn, but it's always turn when you hit the mirror. Okay? All right, so let's look at some examples and we'll talk about some attributes. We did this one here. This one is an interesting thing. We need to, what's the word? Draw on some focal points. So that's like 6.15, so that's like 3.75, so maybe like right there. Okay. So there's my focal point. All right, so my object is at the center of curvature here. That's what's going on. So I'm going to draw my first line, which goes to the mirror, and then it goes through the focal point. And the next one goes through the focal point and then out parallel. And if I draw this just right, you'll see that my object and my image are the same. So this one has, so remember, for our attributes, it's either real or virtual, magnified or reduced, and upright or inverted. So this is inverted because it's upside down. It is the same size. It might look a little different, but it's pretty much the same size, and it is real because I could project it. Okay. This one is inside the focal point, and this one is way inside the focal point. I'm not sure which one we want to do. Let's do this one first. These all have the same focal point, so that was like 3.75-ish, so right in there. So there's my focal point. I'll put one on here. 3.75-ish. 0.75, I mean. Okay. All right, so on this one, I'm going parallel, and then through the focal point, and then here I'm going to go through the focal point, and then parallel. And you can see now my image is way the heck over here. So it's still a real image because I can project it. It is this time magnified, and it is inverted. Okay. Now this one down here will also have the same focal length, so we'll do this one. Look at a few. So this time I'm going to go parallel and through the focal point. And then I'm going to extend this one on the other side because I see something. Do you see how the focal point is over there? That's not ever actually going to hit the mirror, so what I'm going to do is I'm going to extend it off this way. And then I'm going to pretend that it hit the mirror here and then go off parallel. This is the hard one. Okay, so my image is right here. So this is a concave mirror, but it does produce a virtual image because I can't put anything there. So your eyes could see this. This is how you get that magnified image when you are looking at that close-up mirror, right? It is magnified and it is upright. We were able to see that, so now we can see why that happens. This line here, I have to extend the other direction, and that's a little weird, I know, but that's how you draw this ray diagram. That's what your eye can perceive, okay? Just a couple more examples that hopefully are fun. So this is, my center of curvatures are marked here. That's like 3.5. So that's like here, 1.75 is going to be my focal length. Is that the same over here? Yep, 1.75. There's my focal length. And then here is another fun one. That one's 3, so 1.5 is my focal length. And then what about this one? Also 3, so 1.5 is my focal length. Okay. So on this one here, we're gonna draw it off of both mirrors. So we're gonna have an image from this mirror and an image from this mirror. Okay. This object is right here, so it's going to be from this perspective. This is a convex mirror. So when I draw them, let's see, oh gosh, this is going to be a ridiculous image. There's my parallel. It would go that way, but it's going to go this way instead. And then here we go toward the focal point, but when we get to the mirror, it bounces off this way. Which extends it over here. So oops, I didn't really draw that. There's my image. Okay. And then for this other one, same idea. I'm going to go parallel. This is also a convex mirror. So then I'm going to go to the focal point. And then on this one, I'm going to go to the focal point. And then it's going to turn parallel this way, but those lines are never going to meet, but they do meet over here. So here's my image right there. It's almost on the focal point. Okay, so I've got 2 images there. Both of them are virtual. Both of them are reduced, and both of them are upright. Okay. last one that we'll look at here, this one's fun. I like this one because we're going to make an image and then we're going to reflect it off of this mirror. So this one is a concave mirror. So I'm going to do the same set of lines though. This time it's not going to go through. So there's the first line. It goes to, and then it goes through the focal point. So it goes off that way. And then the next one goes through the focal point. And then out parallel. Does that look parallel? That looks pretty parallel. And so there's my image, which is my new object. Okay, this is kind of what telescopes and things do. They just do multiple reflections. So this time, now I'm going to go to parallel, whoops, let me get that a little closer, parallel to the mirror, and then through the focal point. See, I'm dashing it on the other side of the mirror there. And then the next one goes through the focal point. Let me line that up a little better. No, it looks terrible. Okay, there we go. To the focal point, but it can't go all the way there, and then back parallel. But I extend it on this side, so right here is my new image. So this one is a real inverted magnified image, and then this one is a virtual. It would be upright because its object is here, and it is reduced. In fact, it looks like it's smaller than the original, so that's fun to think about too. So I know that was a long video, but it's good to do some practice. If you can do the rest of these on here, and if you have any questions, make sure you ask your teacher. Okay? Thanks for watching.